So in this video, we'll be going over the example of three blocks that are attached to one another and an applied force being acted on one of the blocks. So the problem says the first block on the right is twice the mass of the other blocks. The external force that's being applied is 800 newtons. And then the entire system accelerates at a rate of 2.5 meters per second squared. We can ignore friction. And we're asked to find what is the mass of each block, and we're asked to find what the tension in the cords are that's connecting the blocks. And those tensions aren't necessarily equal to each other. So the first step is to identify how many different free body diagrams we can draw for this particular problem. So I'm going to start by just labeling these blocks. I'm going to call the first little block, block 1, second little block, block 2, and then the larger block, block 3. So we can draw a free body diagram for each of these individual blocks. So we have block 1, block 2, and then block 3. Then we're told information about the entire system, and so the entire system would be, if we were to draw a free body diagram for all three blocks, and that's our entire system. So block 1, 2, and 3 together. And then kind of following that same logic, we can separate the system into blocks that are attached to one another. So we can do block 1 and 2, and then we can do block 2 and 3. You may be tempted to say we can do block 1 and 3, but we have those blocks separated by another block, and so those two aren't connected, so we can't group them together in terms of a free body diagram. So the next thing we're asked is, which of these free body diagrams can we choose to use for our solution? And so I kind of alluded to one of them, and that is, we're told in the problem that the entire system accelerates at 2.5 meters per second squared. So that means all of the blocks taken together, and we have that external force being applied. And so that will be the free body diagram for all of those blocks together. And you can think of them as almost one big block. So all we care about is that there's an external force being applied and all of these blocks are grouped together. So that will be our first free body diagram, because what that will allow us to do, we have a force and we have an acceleration. We can solve for the mass. So a free body diagram for blocks 1, 2, and 3 combined. And so that gives us the ability to solve for mass. Then we're asked to find the tensions T1 and T2. And so if you look at T2 for starters, I'm going to circle this first block. And if we look at that block, if we were to draw a free body diagram for that block, we would just have one force in the x direction. So we've isolated that tension force. And so we should be able to solve for that tension force. So we'll use block 1 as a free body diagram, and that allows us to solve for T2. And then we need to somehow be able to solve for T1. So we want to choose some sort of system that involves T1. And there we have two options. We can either choose block 1 and 2 together, where we'll have one force, which is the tension force being acted on that system. And that's the one that I'm going to end up using. So that's block 1 and 2. And that's to solve for tension 1. You could also choose to use block 3, which is the big block. And there we know the external force being applied, and there's also a tension force being applied to the left on block 3. So you could, in theory, solve for tension 1 in that. And actually, if you do, you're going to get the same result. So choose one of those two options, and then whatever one you don't do, that's a good check and also very good practice to see if you get the same result. You know what you should be getting based off of your first answer, and so it gives you practice drawing a free body diagram and solving for everything. And then finally, there's one big key about this problem. We're told that the entire system accelerates at a rate of 2.5 meters per second squared. So I'll call that 1, 2, and 3 together is equal to 2.5 meters per second squared. But we know that when blocks are connected, they must individually be accelerating at the same rate. That would be, this is comparable to if you're driving in a car and your car's accelerating at some rate. It's the same sort of idea of if you're in the car too, then you're accelerating at that same rate with the car. You don't have a different acceleration. And if you did, that would be a problem because that means you're probably going through the windshield or something along those lines. So the key to this problem, is that the acceleration of block 1 is equal to the acceleration of block 2, which is equal to the acceleration of block 3, which is the acceleration of all of them together, which is equal to 2.5 meters per second squared. So we know the blocks are accelerating in the x direction, so we're expecting a net force in the x direction on our free body diagrams. And so let's go ahead and draw in the ones that we wanted to draw. This first one is for the entire system, so all the blocks together. We have a weight force downwards, which is equal to 4m times g. We have no acceleration in the y direction. These blocks aren't moving up and down, so the normal force from the ground is going to balance out that weight force, F sub n. And then we have an external force, F, being applied to the right on the entire system, and that's equal to 800 newtons. For block 1, we have a weight force downwards, which is just equal to m times g. We have a normal force acting upwards that balances it. And then we have a force to the right from the cable, which is tension 2. And then for blocks 1 and 2 combined, we have a weight force downwards. And that weight force is equal to, is it 1 mg or is it 2 mg? So since we're combining the first and second blocks, it's going to be 2m times g for the weight force. Balancing that weight force upwards is the normal force, and that's going to give us a net acceleration of 0 in the y direction. And then we have the tension force being applied by the cable, which is T1 to that system. So we have a net force in the x direction since we have acceleration in the x direction, so everything looks consistent here. So we don't need to deal with the y direction because a sub y is equal to 0. And so we're going to just be dealing with the x direction. So we're going to use Newton's second law, which is the sum of the forces in the x direction is equal to the mass times the acceleration in the x direction. So let's remind ourselves what our plan is. Using the first free body diagram, we are going to be solving for mass. The second free body diagram, we are going to solve for T2. And then the third free body diagram, we're going to solve for T1. So starting with the first free body diagram, we have the sum of the forces in the x direction. We have an external force being applied, which is F. The system is comprised of the 3 blocks, which is a total of 4m for mass. And we know the acceleration is 2.5 meters per second squared. So solving for m, we get a solution of 80 kilograms for m. And we're asked for what's the mass of the blocks. So block 1 equals block 2, which is equal to m, which is equal to 80 kilograms. And then block 3 is equal to 2m, and that's equal to 160 kilograms. So now that we solved for the masses of the blocks, we can now solve for the tension in the cables. So using the second free body diagram for the first block, we sum the forces in the x direction. There's only the tension force acting to the right, and that's T2. We know the mass now of that first block, which is 80 kilograms. The acceleration for that first block is the same as the acceleration for all the other blocks, which is the same for the overall system because they are moving together. So the acceleration for block 1 is 2.5 meters per second squared. And so we end up with a tension of 200 newtons. Finally, we use the third free body diagram, which is the system of block 1 and block 2 together. So that gives us a total mass of 2m. The force acting on that system is the tension force to the right, and that's T1. And so we know that all the blocks are moving together, so again, the acceleration is 2.5 meters per second squared. So solving for T1, substituting in 2m, since our system is comprised of 2 masses, we find a tension of 400 newtons.